everyone, and welcome back to my online teaching platform. Still on implicit function, we have one of the past questions here, that is YC. If a bracket of 1 plus x squared multiply another bracket of 1 plus y squared minus px squared is equal to 0, where p is a constant, we are to show that xy multiplying a bracket of 1 plus x squared dy dx is equal to 1 plus y squared. All right. So we start with a given implicit function. So let us look at how best we can get, or we can show that the left hand side is equal to the right hand side. All right. So we have a function which is, so my solution here, we have a function which is a bracket 1 plus x squared multiplying 1 plus y squared minus px squared equal to 0, where p is a constant, where our p is a constant. So we are going to use the implicit way of finding dy dx. So this is an implicit function. So we know how to go about it. Anytime we differentiate the dependent variable y, the result will be multiplied by dy dx. And I think we have discussed, or we have learned how they derive that particular rule in one of our previous lessons. All right, so it's not anything difficult. Now we have two brackets multiply each other. So you could say that we are going to apply a product rule over. We are going to apply the product rule. So you can name here to be your u, and name this bracket to be your v. All right. So when you differentiate your u, then you can maintain your v. So let's look at it. So we are going to differentiate our u, which is the u prime, then you maintain your v, plus you maintain your u and you differentiate your v. Then minus minus px squared. So we are differentiating with respect to x. We are going to get 2x multiplying p, since p is a constant, equal to 0. All right. So we know our u to be 1 plus x squared. So when you differentiate 1 plus x squared, you are going to get 2x. Then you maintain your v, which is 1 plus y squared. You close it nicely. And plus, you now maintain your u, which is 1 plus x squared. And you differentiate your v, which is 1 plus y squared. When you differentiate v, you are going to get 2y, but the result will be multiplied by dy dx, which is the same as y prime. All right. Then equal to positive 2xp. We have transposed the negative 2xp to the right hand side. So we continue. We are going to get here to be, so let us bring the term with the dy dx. So we have 1 plus x squared in bracket, but I think we can bring the 2y first because we have 2y here. Then we open bracket 1 plus x squared. Then we have our y prime. All right. Multiplication is completed. Then equal to 2xp minus 2x multiplying 1 plus y squared in bracket. All right. Now let us look at what we are supposed to get. We are to show that, so whenever you are working, you have to pay attention to what you are supposed to find. This is what we are trying to get. So xy multiplying 1 plus x squared in bracket dy dx. So let us go back to what we have done. Now you could see that here we have the y, but we don't have the x. What we have here, is the same as what we have in the question. Here 2 is y prime, which is the same as, so we have this one, we have this. Here is left with x. All right. Then we have to also work on the right hand side. So since there's no x in the the expression in the left hand side, we need to multiply every term by x. So multiply through by x, and this will give us, so you multiply every term by x, so we are going to get 2xy, then open bracket 1 plus x squared. So we have this x multiplying this particular term, then you have your dy dx, then the 2x will also multiply, sorry, 2xp will be multiplied by x, so we are going to get 2x squared p. Then the x will also multiply these terms, so we are going to get 2x squared multiply 1 plus y squared in bracket nicely. Now, we're given an equation in this form, x squared plus 1 in bracket multiply, I think it was by the same thing, addition is complete, but let me use what is given. So 1 plus x squared, then 1 plus y squared minus px squared to be equal to 0. So we can make px squared a subject from this equation, the first equation. So we are going to get it as px squared is equal to 1 plus x squared multiplying 1 plus y squared. So you will now plug in the value of px squared into this equation. So we can name this one equation 2. So we can name what we got as our equation 2. Okay, when we differentiated the function, what we got, we named that one as equation 2. Then you will now make px squared a subject of the given function, implicit function. Then when you are done with that, you plug in the value of px squared into the derivative of the implicit function after you have multiplied through by x. So we are going to get 2xy multiply 1 plus x squared y prime is equal to, so we have x squared p, which is the same as px squared y. So we are going to replace the px squared with its value here. So we have 1 plus x squared multiplying 1 plus y squared. Alright. Then minus 2x squared also multiply 1 plus this already here, so I'm just repeating it, y squared. Alright. So let's continue. So we need to now simplify the right hand side, because the left hand side is getting close to what you are supposed to. We are very close to what you are supposed to get. So we have 2xy 1 plus x squared, then y prime. Now let's look at this one. This is one term, this is another term. Now you can see that they have a common factor. They all have 1 plus y squared. All of them have 1 plus y squared, and they also have 2. Yes. So that 2 is common to all of them. So we can bring 2 out. Or if you want to maintain the 2, you can maintain, but let's bring it out. So you can bring it out 2 multiplying 1 plus y squared. Then, so this becomes the highest common factor. So when you divide the first term by 2 multiplying 1 plus y squared, you'll be left with 1 plus x squared. This is the only one that will be left. Then minus, you deal with the second one too. When 2 divides 2, you are going to get 1. When 1 plus y squared divide 1 plus y squared, we are going to get 1. So we are left with negative x squared over here. All right. So we now have it to be 2xy multiply 1 plus x squared y prime, then equal to 2 multiplying y plus y squared. Now this cancels this, and you are left with 1 in the bracket. Alright, so we are going to get 2xy multiplying 1 plus x squared y prime equal to 2 multiplying 1 plus y squared in this form nicely. Alright, now what we are supposed to get doesn't have 2 here. It's only xy. So we need to divide through by 2. So we are going to get xy multiply 1 plus x squared dy dx equal to, this one also cancels this. So we are left with 1 plus y squared. So you could say that this is what the question is demanding for. So we can now conclude that our xy multiply 1 plus x squared dy dx is equal to 1 plus y squared. So now we have shown that xy multiplying a bracket of 1 plus x squared dy dx is equal to 1 plus y squared. Thank you for watching. Please do not forget to subscribe to my YouTube channel, Math with Ebefa. More videos will follow. Bye.